Welcome back, YouTube. You know what time of day it is? We're going to solve another question from the Blind 75 list of LeetCode questions. For 75 days straight, we're solving one question per day from the Blind 75 and calling it the Blind 75 Challenge. Today we have a problem called Find Minimum in a Rotated Sorted Array. Let's see what the question asks us. So suppose we have an array of length n, and it's sorted in ascending order and it's rotated between 1 and n times. For example, the array nums 0, 1, 2, 3, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2, and it was rotated 4 times. Similarly, we have 0, 1, 2, 3, 4, 5, 6, 7, and it was rotated 7 times. So what we want to do is, given the sorted array nums of unique elements, we want to return the minimum element in the array. And then as a final constraint, you must write an algorithm that runs in log of n time. And if we remember from my big O analysis video, which by the way, I'll put a link down in the description to that, we know that what this is actually asking us to do is just split the array in half each time we pass through it. So let's take a quick look through our examples. So we've got example 1, we've got the array nums and it's equal to 3, 4, 5, 1, 2, and the output, of course, is 1. The explanation says that the original array was rotated 3 times. Example 2 has 4, 5, 6, 7, 0, 1, 2, and of course the minimum number in that is 0, and it explains the original number went from 0 to 7 and was rotated 4 times, and example 3 has the exact same thing. So one thing we can kind of try and start to think about is, how do we find a minimum number normally if we have, say, an unrotated sorted array? Well, normally we go to binary search. This works by just picking a midpoint in the array and comparing that to the number that we want to find. If it's larger, then we take the first half of the array. If it's smaller, then we take the second part of the array, and we just split the array in half every single time until we're either left with the value that we're looking for or nothing, and we say that the value isn't present. So let's break down some of the examples. You'll notice that we can kind of split this in half. You can see that essentially we have 2 sorted subarrays within the complete array of nums. So we can actually have a left and right pointer, and our goal is to make the left pointer point to the start of the smallest subarray and the right pointer to point at either the end of the array or the inflection point. And just as a general note, if you ever see any rotated array problem, just know that the optimal solution is almost always some form of a binary search. You just have to figure out the conditions where you need to go left or right, and that's usually the hardest part. All you have to really do is think about how to manipulate the array to go left or right. Let's work through a solution and hopefully it becomes more clear. Alright, so let's start by just setting up our left and right pointers. We want the left one to be initialized to 0 and the right one to be initialized to nums.length -1. Next up, we just want to set a while loop, and we're going to loop while left is smaller than right. Then we're going to want to find our midpoint, and to calculate this, we're just going to look at left plus right negative left, and we're going to divide that by 2. And then finally, we just want to decide which route we're going to go. So if nums at the midpoint is larger than nums at right, then we want to set left equal to mid plus 1. Else, we just want to set right equal to mid. And we just need to fix a misspelling here. And then finally, we just want to return nums at left. And that should give us the smallest value. Let's go ahead and run that. And there we go, yet another question in the books. This one just goes to show that if you already know binary search, you can apply it to a wide array of questions. So be sure to solidify your knowledge in these kind of topics, and you'll be able to more rapidly find solutions to these kind of problems. Well, if you like these kind of videos, please remember to like this video and subscribe to the channel. I really appreciate you guys watching, and I'll see you tomorrow for another question about arrays.